This video is pertaining to slope, and in particular slope as the average rate of change of a graph, and also the slopes, how the slopes relate with parallel lines and perpendicular lines. This first video, I'm going to split it into two. It shouldn't be too long, but if it's all together, it will get long. So this first video is on parallel and perpendicular lines, a little bit on just basic slope, and then the next video will be more on the rate of change interpretation of slope. So slope is the average rate of change. So the average rate that our y value changes in relation to our x. And you should recognize these equations. M is equal to m is our slope, and y2 minus y1 divided by x2 minus x1. And we oftentimes write this as delta y divided by delta x. This triangle is delta, and it means change. Change in y divided by the change in x. I'm just going to throw up a couple other equations here because they do relate in. Sometimes we'll replace our y1 and our y2 with f of x and f of x1 and f of x2. So I'm just going to write that here. Sometimes you'll see this as m is equal to f of x2 minus f of x1 divided by x2 minus x1. And the other thing, just a quick reminder while we're here, if we have an equation in slope-intercept form, we have mx plus b, so this is our slope. I'm going to clear these drawings. Parallel lines. Parallel lines are two non-intersecting lines that lie in the same plane. So we want two lines that don't cross, but not only don't cross on the paper that we're looking at, but like never cross if we go all the way out to infinity. And the way to achieve that, the mathematical way that happens is when those lines have the same slope. So when we're looking at a line, we want to, we have an equation here for a line, y is equal to 3x plus 1. All of the parallel lines will have a slope of 3. And then we can recall this point slope form of an equation. We have y minus, when we have a point y1, x1, or x1, y1, we have this equation, y minus x1 is equal to m times x minus x1. So this is a way to, if we have a slope and we have a point, we can generate the equation for a line. So in this case, let me bring up my annotation. In this case, we have 3x plus 1. We said the slope of all our parallel lines is going to be 3. So m is equal to 3. And this is our x1, y1. So x1 is -2, y1 is 5. So we have everything we need to plug into this equation. So we have y minus our y1 is 5 is equal to m, which is 3, times x minus our x1. So minus -2 becomes plus 2. And this is our point slope equation of our line. If we want to get this into slope-intercept, then we have to solve for y. So we can go ahead and do that. Y minus 5 will distribute this 3. It becomes 3x plus 6. We can add 5 to both sides. So y is equal to 3x plus 11. So this is our slope-intercept equation, and this is our point-slope equation. And you should check and make sure that when you're answering questions that you put it in the appropriate form. If it doesn't specify, I'm kind of lazy and I kind of leave it here, but you have to find out what your professor is looking for. Perpendicular lines are two lines that intersect at a right angle. So they make a right angle at their intersection. The way we achieve this mathematically is the slope of a perpendicular line is the negative reciprocal of the other line. So if we have if we have something that looks like y is equal to 5x plus 3, well, the slope of the perpendicular line would have a slope of this 5 is like, we can think of this as 5 over 1. So the slope will be the negative of it, and it's going to be the reciprocal, 1/5. Likewise, if we have something that's like y is equal to 1/3, negative 1/3 x minus 10, we're going to take the negative reciprocal of 1/3. So negative and negative is positive, and this becomes 3 over 1, or just 3. Okay, so there's some problems at the end of the chapter that have in general form, which is this equation here, where we have x and y and our intercept are all on one side, and we set everything equal to 0. So when we're looking at this type of equation, we first have to get it into slope-intercept form to find out what our slope is. So we can take this, we're going to solve for y, so we're going to subtract x and add 12 to each side of the equation. So we get 3y is equal to negative x plus 12. We'll just divide both sides by 3 to solve for our y. We get y is equal to negative 1/3 x plus 4. So this is our line. So the slope, the perpendicular slope would be m is equal to negative 1/3. We're going to take the negative reciprocal, so it becomes positive 3 over 1, which is 3. I didn't realize that was the same example there. So this is the slope of our any line that's perpendicular to this line. And then we want to take a look. We want it to go through our point is -2, -6. Just double checking that, -2, -6. So now we go back into that point slope of our form of our equation. We have y minus y1. Well, minus -6 becomes +6 times our m, which we said was 3. X minus x1. Well, x1 is 2, so this is -2, so this becomes +2. And we can solve this. Again, usually like they want it to go back to the form. So in this example, we're going to go back to our standard form, our standard equation, where we have everything on one side. So this is y plus 6 equals, distribute this 3, this becomes 3x plus 6. We have 6 on both sides, we can cross those off, and we're going to subtract a y. So we get 0 is equal to 3x minus y. Okay, that's the gist of the parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have the negative reciprocal of the slope. And the next video will focus more on slope as rate of change.